Welcome to SF Commercial Property Conversations with Bruce Bean, where Bay Area investments meet expert insights. Get ready to unlock the strategies of commercial real estate success.
So today we have Natalie Tse with us, and Natalie is a structural engineer. And Natalie, it's great to talk with you. I know you grew up in Canada, but now you are in California. So give us a little history of how you got here.
Yeah, no problem, Bruce. Thank you so much for inviting me to join you today. I've been in the Bay Area for a little more than 21 years. I moved here in my late 20s after getting married to my husband. And we now have three kids. We live just north of Berkeley in El Cerrito. It's a small city, but it's a wonderful city. And I've been practicing structural engineer since I moved here. So, been at multiple firms, but now I'm at a mid-sized firm called IDA Structural Engineers.
So tell us a little bit about your practice. You're very passionate about making those buildings stay together.
Yeah, a, a big part of what we do is designing for the infrastructure basically the skeleton of buildings so that they can withstand the forces that are imparted on them, whether that's dead loads, their own self weight with finishes and other components, or live loads. So that means human loads and um, say you have a building, want to have a big party on the 40th floor, you want to be able to sustain those loads and not feel those vibrations significantly to the point where people feel sick. And of course, since we're in California, we have to be able to withstand earthquakes. So we design a framing system that can allow the building to yield in ways so that it doesn't have long-term impacts and can bounce back to the shape that it is intended to be in.
So
And
I'm
finally,
curious.
like wind loads too. So.
Oh, wind loads, all of those factors. So yeah, wind loads, particularly on windows that might be flying out.
Mhm. And the
So
other thing is, of course, the building to earth interaction, which is um, we rely on our geotechnical friends to give us guidance on seismic loading as well as bearing pressures and appropriate seismic system or gravity systems to to take the loads so that they don't undergo significant differential settlement.
we won't talk about the Millennium Tower then, probably.
We can, but I'm not definitely not a specialist in that department. We can talk to our geotechnical seismic um, engineering friends to give their opinions on that rehabilitation effort.
So I am curious, as you get closer to an earthquake zone, do you engineer differently, or is there a standard throughout the state that you have to match?
So there are historic records of various levels of acceleration. And basically, there are maps that we follow, and these have been documented over the last 100 years or so. And we use those maps and guidance and our understanding of the geotechnical properties of that area where a new building is being placed to set appropriate standards of acceleration for our assumptions as we're designing our buildings. So depending on whether we're putting a one-story building or a three-story building or maybe a high rise, we would tune our system appropriately. And then each building itself, we will work with the owner developer to figure out an appropriate seismic safety level. So it is a function of the owner's desire, but also the city and the jurisdiction also has appropriate levels of um, importance factor that we set our building designs to.
Oh, that was like kind of my next question, whether
Mhm.
the codes also adjust to these particular zones, and it sounds like they do.
Yeah, yeah. And then it's our responsibility to communicate to our clients the level, like the frequency of that level of earthquake motion. So sometimes we will design for greater or slightly less than the design basis earthquake. So a frequency of 976 years is like a common one for a new building. Actually, I think it might be 2000, is 2225 year
Oh, wow.
uh, recurrence interval. And then if it's an existing building, we have a little bit more, um, I think, leeway. We can design to a slightly lower standard of performance, but the owner knows that is the level of performance that we're shooting for.
An existing building, as in a remodel of an existing building?
Exactly. So we are often are requested by our owner, developer, or architect to provide a voluntary seismic upgrade, in which case it's not a triggered mandated required retrofit, in which case we can design to a slightly lower standard of care. But essentially, when we communicate to them, it's a level of um, expected performance, such as are we designing to um, the life safety performance or
Mm,
collapse prevention? And then say you have a very important building where you're designing manufacturing a very important product.
right.
The owner of that building may want immediate occupancy after a major earthquake, because any downturn for that particular building has significant cost as well as material product impacts. So they want to reduce the amount of downtime post-earthquake.
So I'm curious, this all sounds like maybe the insurance companies get involved also.
They do, but the I think the where we provide a little bit more guidance is in these um, PML reports. They're reports that we can provide to our clients to give a kind of better understanding of the level of performance of the building and its likelihood of doing like it's the amount of time that may have to um, occur after before it can be reoccupied.
Okay. So,
Yeah, so it's a measure of risk essentially.
yeah.
Yeah.
And you've kind of also worked in kind of the nonprofit world, helping different structural engineers and doing some surveying. So tell us a little bit about that.
Sure. So this is an initiative that started around 10 years ago. And it was inspired by some of my architect friends who had exposed us to a similar survey where they were trying to understand why there were so few women architects in practice relative to the percentage of women who are studying architecture in school.
Oh,
It's a significant difference. Um,
wow.
Initially, the name of that particular project was the Missing 32% project. And in practice, that means, or in school, it's about 50-50 for architects. And so Missing 32% project really means that in practice, there the percentage of women practicing architecture is about 18%.
Wow.
So there's a significant drop.
So in
And
school,
so,
it's 50-50, but
mhm,
in
mhm.
practice, it comes down to 18%.
Yeah, yeah.
Wow.
Yeah, so there are excellent reports from the architecture side, and those were published around 2014 and 15, I believe. And so once I learned from a women in structural engineering happy hour about the that particular project, which has now been renamed Equity by Design. A friend of mine and I had shown some interest in doing a similar study in structural engineering to understand why there were so few women structural engineers in leadership positions and overall in the profession in structural engineering. So it started off just as a curiosity. And then initially it was more of a gender equity survey, and then it grew to something bigger and better. And that we brought in the topic of engagement and retention in the profession. So in the end, we adapted our survey to really understand what were some of the factors that are influencing long term the exit from the profession to other professions that are of technical nature, that whether it's people going into construction or becoming a code writer or something else that's another viable solution for a career.
So I'm curious, you said earlier that you're very busy right now, so I'm interested in what the current market, well, for structural engineer and for building is these days.
That's a great question. So, I've been, as I said, I've been working in the Bay Area for about 21, 22 years or so, and I've seen the market change quite a lot. And when I first started working here, a lot of the work that I was doing was related to retail work.
Hmm.
So we were building a lot of new construction, and then I transitioned more towards K through 12, which now has kind of grown to use the terminology TK, or
Right,
transitional kindergarten through, I think, also 12, TK to 12. So
right.
that's school type work. There still is a lot of work in hospitals, and that's because there's funding available. We acknowledge that schools, whether it's TK-12 or higher education, and hospitals, medical office buildings, there's still funding for those types of projects. But in addition, there's a strong need in the Bay Area, as there is in many other cities, especially urban areas, for housing, especially affordable housing.
Right.
Affordable housing continues to be a big problem for us in the Bay Area. We are constantly looking to partner with different groups to find different ways to create more developments. And fortunately, there has been some funding made available through various big, large organizations, but I do have concerns that we don't know how much longer there will be funding, and if there have been impacts from either local, state, or federal funding that have changed over the years.
Yeah. No,
Yeah,
well, certainly, I just recently was speaking with a affordable housing consultant, and he is so busy he can't even think straight, I don't think. I mean, it is just crazy out there. And there's obviously concern about funding, but right now there are a ton of projects in the housing world going on, or at least
yeah,
affordable housing world.
yeah.
So,
Yeah, we're always trying to find ways to do things smarter, faster, better, considering different approaches and finding the right number when it comes to heights of buildings. And of course, like floor to floor heights, different assemblies have different restrictions on what we can and can't do. I know that some groups have been looking into various technologies with mass timber to create more sustainable solutions. And there have been some benefits to using some of these mass timber systems in terms of reducing, like it becomes more like a modular type system.
right.
And you can shorten like some of the assemblies are less thick, so you can get another level in some cases.
Oh, oh,
But it still becomes a challenge because you can only use mass timber generally for flat surfaces. We haven't, there are tons of universities that are doing research on viable mass timber related vertical systems, meaning lateral systems,
oh, interesting.
but hasn't quite penciled out that well yet, and I don't think there have been that many that have built in seismic regions. So
Yeah, I'm not sure
so
I
it
want
tends
to
to
be
be
building
kind of a
the
hybrid system.
test
Yeah.
in the system. So
Yeah.
that's very interesting, though. So horizontally, they're fine, but vertically, we still kind of don't know.
There have been some systems that have been tested and some reports that have been developed, and I think some groups have been trying to develop patented type systems
Oh,
or basically getting the approvals so that you can use it, that any engineer can use that system, and that takes time, of course, and applications can be cumbersome and time consuming. So.
well,
Um, I think a big challenge with it is getting things to pencil out when it comes to overturning. So the connections can be quite challenging. And so people have, so far, a lot of us have been relying on more conventional systems, whether it's buckling restrained brace frame systems or using concrete shear walls, reinforced concrete core systems, and having potentially outriggers to help balance out some of the loading. But I have yet to see um, something other than the more conventional systems utilized in the Bay Area. So, unless have you heard of anything
no, no,
that's
but only I'm thinking in my mind that,
mhm,
bolting metal to metal is very positive, whereas
mhm.
bolting wood to wood, maybe not uh, sustainable in an earth.
Yeah, yeah. Bolted connections can be challenging with wood member connections. So there's sometimes we do still use a lot of steel in a wood frame system to make things pencil out. But then that impacts the floor to floor heights. So,
Oh,
and
that, yeah.
yeah. And another challenge with the mass timber system is really in fire ratings too. So especially
Oh,
if you're using mass timber for um, a residential building, I think once you get to a certain number of stories, you have to finish the ma the um, the decking system.
oh,
So
yeah.
it kind of loses the appeal aside from sustainability and carbon emissions perspective, in that you won't get to see the beautiful finishes of
Right.
the wood,
Right.
which contributes to well-being, and overall feeling of nature.
So I'm curious, is AI starting to enter into the structural world? What's
Oh,
happening there?
yeah, it's
Oh,
been
yes.
Yeah, it's been in discussions for quite some time now, and at the national level, we've been thinking about it for a long, long time. At least showing interest, and there have been initiatives at the national level. We call it the NCSEA, the National Council for Structural Engineers Associations. So there's been funding to have various groups to execute on deeper research on how we can effectively as and what's the right word, to effectively implement and utilize AI in a way that is sustainable and safe. Because obviously we want to use AI in we don't want to take too many risks, but we also don't want to be behind our competitors in what we can use it for to improve the efficiency of how we design things, and also just use it to our benefit to make much more efficient systems, and processes in our design methodologies.
Well, yeah, I suspect that you're in the same quandary that many industries are in,
Mm,
uh, that yes, AI can generate all this great information, but is
mm,
it all correct? So then you have to go back and double check it and make sure it's works with the calculations that you've used in the past or whatever. But
that's right.
I can only imagine uh, that yes, it would probably speed things up, but then are you sure it's the correct calculation? So I don't know.
Yeah.
Yeah.
Yeah, there's still quite a bit of hesitation, and obviously a lot of anxiety as well from especially from leadership and business owner standpoint. So it's important for a lot of firms to be aware of what is available, and to at least stay on top of like current at least documentation, and there are lots of articles on ways in which people are using it. And there have been kind of like groups to help each other navigate this world together. So you don't have to feel alone. And there are obviously a lot more resources than you can probably have time to review and assess. But there are a tremendous number of resources that are available. And for any of the listeners out there who are structural engineers, I do encourage you to look up on NCSEA's website to get some resources, because NCSEA is very committed to providing some resources for everybody to lower that anxiety level and to allow us to grow together on how we can best use systems to our advantage.
That's fantastic. Well, I assume you're probably using it in marketing and emails and sort of those standard things that are not structurally related. But
Yes.
yeah,
Yeah,
yeah.
those are definitely beneficial to all of us, no matter which level, how many years of experience you do have. Um, Especially proofreading your emails or even social media posts or reviewing marketing materials as you're sending them out before you kind of cross the T and dot the I,
Yeah. No, it's
so to speak.
fantastic for that kind of use.
Yeah.
That's great. So, well, let's pause for now.
Mhm.
And where can people get a hold of you, Natalie?
Um, Probably the easiest way is just through LinkedIn. I'm guilty for being a regular LinkedIn user. Um,
I don't think you should feel guilty about that. I think that's great.
um, I do use it probably more frequently than my followers want me to. Um, but I try to publish important content that is important to elevate and voices that are that I think are important to acknowledge. I think there are a lot of things that we can celebrate, and tools that we can share with each other to improve the way that we think and do things. And while I have this microphone, I encourage people to really take the time to reflect, and especially about what brings you joy and fulfillment in life, and to help each other maximize each other's potential.
That is a fantastic conclusion. In 270 podcasts, I've never had such a great conclusion. That's fantastic.
Really?
I love it. That's great. Well, let's
Thank you.
continue our conversation. I think we should converse in another 3 to 6 months and see what else is going on in the structural world.
Thank you so much, Bruce. I love the opportunity to talk to you and look forward to staying in touch.
Very good.
That's a wrap on today's journey through the SF commercial real estate scene. Ready to share your story? Visit sfcommercialconversations.com/guest. Your insights could lead the next conversation.